Okay, you've got chassis, suspension, and unsprung weight. Quick poll. What's more efficient for a race car, a stiff chassis or a sloppy chassis? Stiff, why?
There's less friction because it doesn't move.
Yeah, well, anytime you're flexing a chassis, what's happening?
Friction.
Well, heat from the chassis and friction on all the parts, right? So for the highest performance, you want a really stiff chassis. You don't want one like, made out of a noodle that flops back and forth. You want it to be stiff. And again, we measured in the 0305 car, put it up on the, after doing some testing, put it up on the bench and weighted it, and we found out it was about as stiff as a Corvette's chassis. It had almost no deflection when you put weight on it for normal things. What about the suspension? Suspension are what keeps the wheels up and down. What do you want? You want no suspension, soft suspension, or medium suspension? What do you think is best?
Medium suspension. If you go too bulky, it's way too heavy. And if you go too soft, then you run the risk of destroying your suspension when you need to play it.
Yeah, and if you have no suspension, you bounce, right? All that bouncing is going to do what? You're going to stress things, you're going to twist things, the driver's going to go crazy and have a backache, but you're also going to lose energy because you're going to be bouncing. Every time you bounce, you're going to be somehow, even stiff suspension, twisting things. You want it to be somewhat firm, but you want the wheels to never do what? Leave the ground. You want to keep the wheels on the ground, right? You don't want it too soft, because if it's too soft, you're going to either bottom out or, be sloshy when you do it. You're also going to lose energy. There's a balance in there, tuning the suspension appropriately. We got air shocks on the 0305 car for suspension, and we've got coil shocks installed, steel springs in the new car. What do you think's more? What do you think loses more in terms of actually a suspension? What has more loss of energy? The air shocks or springs?
Air.
Springs. They generate more internal heat on the spring shocks than with the air shocks. However, what are the advantages of spring shocks? Really easy to adjust the ride height. It's difficult to adjust the ride height with air shock and keep it proper. So spring shocks are less efficient, but much easier to get a uniform ride height on them. Where does the energy go in a spring shock that you lose? Where does energy always go when stuff's moving? Heat. Right. Okay. What's unsprung weight? We're talking to the mechanical engineers here. What's unsprung weight?
Extra material on the vehicle that doesn't need to be there.
No, you got sprung and unsprung, suspension, not suspension. What part of a car is sprung? Everything that's
The cab.
on the suspension, right? What's the unsprung part then?
The frame.
The wheels. The things that are below the suspension. Basically your hubs, your wheels. Now, the sprung weight on the car, as you're going down the street, what does that do? Nice and smooth, because the wheels are going like this, right? But what's the unsprung weight? Those are the wheels going up and down. So what do you think is better to have, sprung weight or unsprung weight? Sprung weight. Unsprung weight causes more losses because it's moving up and down and bouncing. So you want to have what? Your wheels, your tires as light as possible. Now, why do we have two motors? That gives us a heck of a lot more what? Weight. We have a lot more unsprung weight, so we're losing. One motor would have more unsprung, would have less unsprung weight, be better. So why do we have two? What's the reason? What was the design decision for us having two? There's a different design decision originally and perhaps now. But give me some reasons we want two motors if you actually have more unsprung weight, which is bad.
You get
Why?
Torque out of them?
Well, you could, but torque is roughly proportional to the amps you put in. Right now, we're limited by the number of amps, the battery, and the rake and output. Those motors can handle 100 amps. We can't output 100 amps. We can only output 56 amps maximum from the current battery pack. We'll have to reduce that by 25% for the new battery pack. We only have 20 kilograms perhaps. And we're not going to get 40 amps from the array. The old array, we maybe at the best of times got 16, 17 amps. The new array you might only have 8 or 9, 8 amps maybe, 6 amps. Depends on where we are in Texas. So why have two motors if we could get the same torque out of one motor by giving it twice as much current?
Isn't it higher efficiency?
Nope, about the same efficiency. If you're not at the end of the motor torque curve for these guys, they'll have relatively similar efficiencies, both motor and motor controller. And running it at 50 amps, we're not doing too bad on the motors. You don't want to run it too long at 50 amps, but you're okay.
It prevents one motor from burning out.
Yeah, what it is heat. If you run one motor even at 50 amps for very long, and you'd start having heating, when would you be running that at 50 amps? When would you need that kind of current? Up hills. So going up long amounts of hills, those single motors might not be able to do it. Having two motors running them at half the current, each of them producing half as much torque, you get the same torque overall, you've dissipated the heating problem. The heating problem that other teams have isn't yours. So we're trading the heating problem that other teams have for some extra unsprung weight. So an efficiency loss in there. Okay. Alignment and scrub. What kind of issues have you got in wheel alignment? Mention them. Front wheel steering. What kind of alignment things have you got?
Toe, caster, and camber.
All right, toe, caster, and camber. What do you want to do? And of course, we all have Ackerman steering, right, to try to help with that coming in. So tell me, what do you want to set it up as? Toe, caster, and camber. You know the names. Give us the story.
Toe, you want to be near 0 degrees.
But you want to be in or out, a little on each
Slightly.
side. Why?
Prevent oversteer.
Yeah. Okay. Camber.
Yeah,
Okay. You need to know, whoever's designing the steering better know what the hell they're talking about when they do this. That's kind of critical, right? You want to make sure you don't have oversteer, but you also want to make sure when you let go of the steering wheel, you want the car to do a little bit of what? Tracking straight ahead.
Yeah.
So you want stability, you want to track straight ahead a little bit. But what happens if you try to overcorrect, like some of our passenger cars used to? But then what happens? What happens to the tires? If you turn the tires in a little bit, what happens? Yeah, you get scrub, right? The tires wear. You want a little, but not too much. But the tires wear because they'll start rubbing because they're not tracking the same. But what also happens then? Efficiency goes down because you're paying for that in energy coming in. So you want the steering to be very carefully adjusted. And will you have to adjust the steering during the race to make sure it's still aligned? Probably. So one thing you want is some tools to allow you to do steering alignment. Do you think you also need to have the car ready in time so you can take it out on the road and test your alignment and check it over rough roads and smooth roads? Oh yeah. Now, for suspension, over a really rough pop-marked road, we could tell you some in Oklahoma that had horror stories like 3-inch heat shoves you had to go over. Imagine going into a 3-inch step at 60 miles an hour. That happened in the 05 car and in 03. And it actually survived. The back end went up, came down, pitched it a little bit, but tracked straight ahead. Didn't go out of its lane. Of course, the problem was our scout vehicle, our lead vehicle, didn't bother pointing this out. So the solar car hit it at full speed. Not a good thing. Okay, so you got to minimize scrub. You have to watch it, but you do want to have the car drive reasonably. You don't want to have the guy fighting it like a fighter plane without electronic control that keeps it stable, right? You don't want to have an unstable car. Stopping and starting. We'll talk about that a little bit. When you're running, you've got what? What kind of energy when you're rolling? Kinetic energy, right? When you stop, that's got to go someplace. Now, what are the 3 things you can do when you're stopping? Well, no. First, coast. no loss, right? We'll see that. Then regen, 15% loss. Finally, brake, 100% loss. Where does the energy go? Heat. Yeah, when you see your driver stomping on that brake and the red brake light goes on, guess what it's time to do?
Yeah, well,
Get another driver. Abe will tell you a story about a driver. We watched him put the brake light on again and again. He swore he never used the brakes. But it's kind of obvious when the telemetry says the brakes are on, and you see the red light going on, but he would swear he just. And part of that is, what do you think you have to do for drivers so they drive appropriately, so they know how to coast down, then use regen? Training, and practice, and the team has to be able to tell him, strategy-wise, when to start it. Hey, yeah, you know, got a car ready? You can do that. If you take anybody, except, Nick, who's and put them in a car, they're not going to drive well. It takes some practice and some time and some experience, because, it's, you're going at reasonably high speeds, and it's not necessarily safe and fun.